Hello everyone and welcome to another scientific video with that process of reactions, and today in this video we are going to discuss how to calculate the mass of Earth. In our last video you all remember we discussed how to calculate the radius of Earth using sunrise method, and today we are going to use that particular value to calculate the mass of Earth. How to calculate the mass of Earth. And first of all, I must have one request from all of you. Please subscribe my channel, because this particular channel is very soon going to be one of the largest scientific vlogging channels in the world. And let's move on. Okay, according to our last calculation, we know that the radius of Earth is 6.396544 multiplied by 10 to the power 6 meters. And we know that the Earth is a spherical object. So the volumetric value of the Earth is given by 4 divided by 3, 5 r to the power 3. And then if the average density of Earth materials is dAV, then the mass of the Earth can be calculated like this. The mass of the Earth will be equal to 4 divided by 3 pi r to the power 3 and dAV, the average density of Earth materials. And as we know, there are plenty of Earth materials in this world. Water has a density of 1000 kilograms per cubic meter, and metal, iron, has 7100 kilograms per cubic meter. Silver has about 10,500 kilograms per cubic meter. Gold has about 17,200 kilograms per cubic meter. So there are different densities for different Earth materials. But anyway, the average density of Earth materials is equal to 5,500 kilograms per cubic meter. 5,500 kilograms per cubic meter. So that by applying this value here and this radius value here, we can calculate the Earth's mass as 6.0316176 multiplied by 10 to the power 24 kilograms. Mass of the Earth 6.03176 multiplied by 10 to the power 24 kilograms. But this is not the proper way to calculate the mass of the Earth, because we know that this particular value is very hard to find. Because as we go into the Earth more and more, due to the huge gravitational pressure, the density of Earth materials is going to be vastly high than the Earth's surface. So this particular value is not that much easy to calculate. So that we have to leave this way. And we have to use this way. Using the law of gravity, we can calculate the mass of the Earth. How can we do this? Let's check it out. Okay, let's say this is the Earth. The mass is me. And there's a small object with a mass m. So that this object will receive a gravitational pull by the Earth towards the center of the Earth. That's called Fg, the gravitational force. So the Fg, the gravitational force, is given by this particular equation. G MEM divided by RE square. So gravitational constant multiplied by the mass of the Earth multiplied by the mass of the object divided by the radius of the object. And also we know, according to Newton's second law, the acceleration of the object is equal to F equals ma. Fg is the gravitational force, m is the mass of the object, and a is the acceleration. So now we can make Fg equals Fg. So G MEM divided by RE square is equal to ma. Now what will happen? These two equations are equal. Now what will happen? M and m will be cancelled out. So that GME divided by RE square is equal to a. This particular acceleration is specially mentioned as the acceleration due to gravity, or the gravitational acceleration. The symbol is g. So g is equal to GME divided by RE square. Gravitational constant, mass of the Earth, and the radius of the Earth square divided by the radius of the square. Now what we have to do is we have to calculate accurately the gravitational acceleration. For that, we can drop an object from a height, we can measure the time duration, we can measure the length, and we can calculate the acceleration due to gravity. But that way is not the correct way, because we have the air friction of the atmosphere. So the value is not correct. And also, now we have a second way which is better than that. That is to use the simple harmonic motion of a simple pendulum to calculate the gravitational attraction. And now let's check how can we do that. Okay. Any simple harmonic motion can be represented by the vertical component of a rotational motion. Vertical component of a rotational motion. Sorry, not vertical, horizontal component of a rotational motion. Any simple harmonic motion can be represented by the horizontal component of a rotational motion. Let's check it out whether it's true or not. Okay. The speed of the rotational motion can be taken as v. So in the speed v, the rotational motion goes like this. And the vertical horizontal component is given by, if this angle is theta, the horizontal component is given by v cos theta. V cos theta. So at this place what will happen? The theta becomes 90. Theta becomes 90 degrees. And cos theta becomes 0. So v cos theta becomes 0. It means the speed of the simple pendulum becomes 0 at here. That is true. And as it goes like this, as it goes like this, and this place, the speed becomes maximum. And now let's check whether it's true or not. Okay. At here, this place, theta becomes 0, and cos theta becomes 1, and v cos theta becomes v. That is the maximum value of v cos theta. And the speed becomes maximum. So very easily we can understand that the simple harmonic motion can be represented by the horizontal component of this rotational motion. Rotational motion goes like this, the horizontal component goes like this. Now we can use this rotational motion to calculate the periodic time. And we have to connect the periodic time to gravity. And let's check how can we do that. The rotational motion needs a centrifugal force. The centrifugal force is given by mv squared divided by r. M is the object, mass of the object that rotates. V is the speed of the rotational motion, and r is the radius of the track, the path. And we know that in simple pendulum we know that the governing force of the simple pendulum is mg sin alpha. Mg goes like this. Mg sin alpha is this component of the weight. Mg sin alpha is the weight. Mg is the weight. Mg sin alpha is this component of the weight. So this component governs the simple harmonic motion. So that we can say that this particular centrifugal force is provided by this component. So mv squared divided by r is equal to mg sin alpha. Now m cancel out with m. Sin alpha we know that this is L, this is R, this is alpha. You can see this is alpha, this is alpha. So sin alpha is R divided by A. R divided by A. So V square divided by R is equal to G R divided by L. Now from that we can get V is equal to G divided by L square root multiplied by R. So V is found. Now we can say that the periodic time is to complete one cycle like this in the simple harmonic motion, or one cycle like this in the rotational motion. So that it's very easy to use one cycle like this to calculate the periodic time. So if the velocity is, if the speed is v multiplied by the periodic time is equal to the circumference of this circle. So circumference of circle is given by 2 pi r is equal to dt. T is the periodic time. Now 2 pi r is equal to v is g divided by L square root r and t. Then r is cancelled out with r. So finally t is equal to 2 pi square root L divided by g. This is the equation for the periodic time. Now what we can do is we can calculate, we can make the simple pendulum, we can calculate for the time duration for 100 oscillations, and we can divide by 100, we can get an accurate value for the t periodic time. Then we can apply this, and we can, as we know the length of the simple pendulum, we can accurately calculate g. and we can apply that G to here, and we can calculate the mass of the earth. And now we are going on to that particular calculation for the next part of the video, and let's move on. Okay, let's move on to the final calculation now. And in last calculation we got that T is equal to 2 pi divided by L divided by 2 pi multiplied by L divided by G square root. And from that we can make the subject G. Subject G is equal to 4 pi square L divided by T. And we know the previous calculation. From the previous calculation we got that the gravitational acceleration G is equal to gravitational acceleration G is equal to gme divided by re square. Here G is the gravitational constant, me is the mass of Earth, and re is the radius of Earth. And now we can equalize that G to this G. G equals G. Now from this we can take gme divided by re square is equal to 4 pi square L divided by T. Now we can make the subject me. So me is equal to 4 pi square L divided by T R is square divided by G. This is the 4, this 4 is 4, 5 is 5, L is the length of the simple pendulum, Re is the radius of Earth, and T is the periodic time, G is the gravitational constant. We know all these values. In our experiment that we did, we selected the simple pendulum with a length of 2 meters, and we calculated the periodic time as 0.8122 seconds. And if we apply this value here and this value here, this one we know, this one we have calculated from the sunrise method, and G, the gravitational constant, we know. And how to calculate this gravitational constant, I will demonstrate you with another new video. And we know this one for the moment, we know this one for the moment, this one for the moment, we know this one for the moment, and we know this one for the moment, and now we know all the values, and we can apply all those values to calculate the mass of Earth. Me is equal to 4 is 4, pi is 20 divided by 7 square feet, and 2 is 2, the length of the simple pendulum. R is the radius of Earth is 6.396544 multiplied by 10 to the power 6 and square of it, and divided by T. The periodic time is this one, 0.2122 seconds. 0.8122 seconds, 0.8122, and the gravitational constant is 6.67 10 to the power minus 11. And now finally calculating this entire piece, after calculating this entire piece, you will get the mass of the Earth as 5.9722 multiplied by 10 to the power 24 kilograms. This is the mass of the Earth. The mass of the Earth. So you get the mass of the Earth 5.9722 10 to the power 24 kilograms, a huge mass. So now this is how to calculate the mass of the Earth using our method, and you all know that now. And I hope to see you soon with another valuable scientific video like this. And until then, wish you all the best and hope to see you soon. Goodbye.